All right, so we are going into lesson 6, which is all about the math class. So make a new Java project, call it lesson 6, and then go into your source and make a new class. And I'm going to call it lesson 6 again. Okay, so up at the top, put in your author, today's date, and I'm going to put in lesson 6, math class. So we're going to be talking about doing some calculations. I'm also going to go in here and even out my brackets. So what we're going to be doing now is kind of using Java to our advantage. So kind of showing you this, that your computer can do the same things as your calculator, but just in a different way. So I'm going to set up a double, call my variable p. If you want to call in the math class, let's type in math dot. And then you can put in whatever sort of argument you want. So in Eclipse, you can look through all of these things that you can do. Some of these we will use, some of them we won't. But the one we're going to use right now is square root. So basically it's square root without those vowels. And remember, square root right here is a method. So what we're going to do is we're going to put in some arguments. We're going to say 17. Note we have to have it be a double because the square root of 17 is not going to be a whole number. If we put in 16, we could make that be int. But it might just be safer to always use a double whenever you're dealing with your math class. So next line, we want to see what it prints out. So system.out.println, and we're going to print p and close your bracket. Hit play, and there's our response. So if you look in your book on page 30, there's these things called signature of the method. So here's a list of the common methods that you will be using in math class. So like ABS for absolute value, POW for power, square root, ceiling. So that basically brings back the next highest whole number. Same with the floor. So min, max, you can use doubles. So random will return a random range given, or random number given a range. Round is going to actually give you back the whole number, and pi is going to be your 3.14159. So if you look at the signature column, this is basically how you have to set it up. So we just did the square root, so we did double square root and then put in what we wanted the square root of. So if you are confused about any setups that we do today, you can come check here for the signature. It's kind of like in Excel when you put in a formula, but you have to set it up a certain way for it to work. So same with Java. So I'm going to come outside of line 10, and I'm going to make my remark, and I'm going to say calculates square root of 17. And I'm going to actually comment this line out. And I'm going to go to a new line, and we're going to test out something else. So let's go with the power. So we're going to say double E equals, and then look how it needs to be set up here. So it's math dot pow, and then you put your variables next to it, or your arguments next to it. So math dot pow, then you put in your arguments. So the nice thing about Eclipse is she had already brought up A and B. That's what you need to put in, so it kind of sets this up for you. So let's take 3 to the second power. Don't forget your semicolon. So we run it, and it comes back with 9.0 because it took 3 to the second power. We did 3 to the third power, 27. We did 2 to the third power, we're going to get 8. But then again, those are all things you could do in your head. So let's change it up a little bit. So go to line 12, and we're going to say 2.08, and we're going to raise it to 3.1174 power. So it also operates the same way. So I want you to look in your book at page 31. There's the ceiling and floor methods that I, kind of told you about a few minutes ago in the video. But it is a very weird topic, and it's probably one of the harder topics for people who are taking this class to understand. So basically, if you look at this drawing, it's a little description of what the ceiling and floor is. So it's kind of like rounding either up or down. So if you tell it to 1.4 to go to the ceiling, it's going to go to 2. You tell it to go to the floor, it's going to go to 1. Or if you have negative 1.6, the ceiling is going to be negative 1 because it's still going up. So if you think about it on a number line, it's not going to go more negative, it's going to go more positive to get to the ceiling. And then negative 1.6 floor is going to be negative 2. So if you can think about it in a vertical number line, then you'll be okay. So let's test it out. I'm going to go back to line 12 and say calculate power. And then I'm going to comment that line out. I'm just hitting the end button to make it a little faster. So I do recommend keeping their spaces in between these just for your own sanity. So we're going to set up our own floor and ceiling. So double P equals math dot ceiling negative 1.1. And it's not ceiling, remember. It's ceil, so C-E-I-L. And then it says there's an error. Let's look. Insert your semicolon. Go ahead and run this. So it brings back negative 1.0. Change the ceil to a floor. And makes it negative 2. If we take that negative off, 1.1, what do you think it's going to be? It's going to go down to 1. So even though the floor was negative. All right, so comment that out. Then I'm going to make a comment at the end. Calculates ceiling. Okay, so we're going to take a quick look at some of the other functions in the book. So if you go back up a little bit, we're going to look at the absolute value. So absolute value is not hard. So double P equals math dot absolute value. And if you put negative 11, it's going to find the absolute value and give you back 11. Easy. If you look at min and max, it's going to have 2 arguments behind it. So you go back into your setup, comment that out, calculates absolute value. So then we're going to have to find the min and max. So double P equals math dot min and give it 2 arguments. So negative 57, comma 5. And we'll say double Q equals math dot max negative 57, comma 5. So then change our print line so we can say the min is plus P, and then system.out.println, the max is space plus Q. And if you look, you can actually leave a space there. I'm going to put one in just because it's more consistent with my program. Go ahead and run it. The min is negative 57, the max is 5. You could even change it. It doesn't have to be the same numbers in there. The next one we're going to talk about is round. So I'm going to go in and comment those lines out. Calculates min to arguments. Next one is calculates max of 2 arguments. And I'm going to comment these out also. So if I say double P equals math.round 2.6, you can probably assume that whenever it churns something out, it's going to round up from 6. So it's going to go to 3. So let's make sure it does that. So system.out.println and P, and then run it, and it does give us 3. Change it to a 4, round it, and it rounds down to 2. So now I want you to try putting a negative in front. So negative 2.4 and run it. Gives you negative 2.0. What about negative 2.6? It rounds up to 3. So it kind of works the opposite of the floor and the ceiling, which I realize is kind of confusing. But hopefully you're okay with rounding, and then the floor and ceiling is the only thing that's a little confusing for you. The real difference between rounding and then the floor and ceiling is the rounding just gives you the nearest whole number, whereas floor and ceiling, floor will give you the lowest number and ceiling will give you the highest number. All right, so take a look at your book. If you look back at our different methods, one of them is called pies, but if you look at the signature, it doesn't need any arguments because pi is a constant. It is always 3.1415965, and it will always be that way as long as I have anything to say about it. So for our needs, math.pi is not even a method. So go back to your code. I'm going to comment the last one out. Rounds to the nearest whole number. We're going to say double P equals math.pi. Make sure pi is capitalized. It does not like this because I didn't put in an argument, no variable, just wrote double. So we have double P equals math.pi, run it, and it gives us good old pi. If you look in your book on page 32, there are some other math methods that you might actually find familiar. So finding the log, you can actually find logs in Java. So it would just be math.log and then whatever you're trying to find the log of. Now it is log base E, which is really ln if you recall correctly. So you can do sine, cosine, tangent, arcsine, arccosine, arctangent, and you can even convert from degrees into radians and back again. You are now ready for the Compute This project, and you are ready to answer your Lesson 6 questions. Good luck!